University of Sri Jayawardenepura. Faculty of Technology. Department of Civil and Environmental Technology. Water Quality Monitoring Practical. In this video you will learn how to use pH meter. The basic principle of electrometric pH measurement is determination of the activity of the hydrogen ions by potentiometric measurement using a standard hydrogen electrode and a reference electrode. Uses of pH meter. To measure hydrogen ion activity in water-based solutions. To identify acidity or alkalinity. Prior using the pH meter, it should be calibrated using color-coded buffer solutions with fixed pH values including pH 7, pH 10, and pH 4. This pH meter consists of LCD display, electrode holder, pH probe covered in a protective cap, temperature probe. This pH meter is already calibrated. Hence, we can start the measuring pH. pH behavior of following solutions will be studied. Sodium hydroxide, hydrochloric acid and tap water. The first step using pH meter is to remove the protective cap from the electrode. The electrode of the pH meter need to be stored in properly capped and immersed in standard solution to help prevent damage in transit. Next, the electrode must be rinsed using distilled water and dried using tissue papers. Then place our sample filled with the tap water beneath the electrode. Then submerge the tip of the electrode and the temperature probe into the sample. Wait until a stabilized result is generated. The LCD shows the measured pH value on primary LCD and the temperature of the sample on the secondary LCD. This sample has pH of 5.91 at a temperature of 28.4. Once the reading is completed, you will need to remove the electrode from the sample and rinse with the distilled water. Then dried out the pH probe properly. Repeat the process again, this time using sodium hydroxide solution as a sample. Submerge the pH probe into sample slowly and allow some seconds to stabilize the reading. pH meter shows the pH value regarding the sample and this has pH of 12.95 at a temperature of 28.0. Then remove the sample. Once again rinse with the distilled water and wipe out the tip of the electrode. Finally, we take our HCl solution as our third sample and repeat the process. Submerge the probe, and note down the pH value. This has pH of 1.71 at a temperature of 27.7. You need to rinse the electrode and dry it out. Now you have to replace protective cap for storage. In this video you will learn how to use the conductivity meter. Conductivity, K, is a measure of the ability of an aqueous solution to carry an electric current. This ability depends on the presence of ions, on their total concentration, mobility, and valence, and on the temperature of measurement. Solutions of most inorganic compounds are relatively good conductors. The conductivity meter consists of LCD display, electrode holder, probe, and further we are using magnetic stirrer, and beakers which containing solutions of the conductivity has to be investigated. The electrical conductivity behavior of the following solutions will be studied. Calcium chloride, magnesium sulfate, and tap water. The three solutions are equimolar to ensure honest comparison. We expect the first two solutions to exhibit higher conductivity and then the third has to be lower conductivity because more charges are present in the first two solutions. Collect 100 milliliters of sample solutions into glass beakers and get them labeled. Switch on the conductivity meter. Rinse the electrode thoroughly with distilled water and carefully wipe with tissue paper. Place the first sample, mix the sample with the magnetic stirrer. Dip the electrode into the sample solution, wait for steady reading. Now the conductivity appears to be significantly higher as we expected, which is 30.2 millisiemens. Rinse the electrode thoroughly with distilled water and carefully wipe with tissue paper. Place the second sample, mix the sample with the magnetic stirrer. Dip the electrode into the sample solution, wait for steady reading. In this case, conductivity appears to be substantially higher than first solution, which is 76.8 millisiemens. Rinse the electrode thoroughly with distilled water and carefully wipe with tissue paper. Place the third sample, mix the sample with the magnetic stirrer. Dip the electrode into the sample solution, wait for steady reading. Note down the reading in the display directly, which is expressed in millisiemens. And now the last sample, conductivity recorded as 40.2 microsiemens. From the presented setup experiments, it can be concluded that comparisons of equimolar solutions reveal that the solutions with the highest charges density exhibit the highest conductivity. In this video you will learn how to measure temperature. Temperature readings are used in the calculation of various forms of alkalinity, in studies of saturation and stability with respect to calcium carbonate, in the calculation of salinity, and in general laboratory operations. In limnological studies, water temperatures as a function of depth often are required. Normally, temperature measurements may be made with any good mercury-filled Celsius thermometer. But in this practical, the temperature probe of the pH meter is used to measure the temperature. Today we are going to measure the temperature of two samples, which is hot water and tap water. In this video, we are using the temperature probe of the pH meter. Then we take sample 1 that contains hot water. Then immerse the temperature probe of the pH meter into the sample. More importantly, do not remove the temperature probe from the beaker until you record the reading. Then note down the temperature value displayed on the secondary display. This sample has a temperature of 28.8 degrees Celsius. Then we take sample 2 that contain tap water. Then immerse the temperature probe of the pH meter into the sample. Ensure that the temperature probe is completely immersed in water. Then note down the temperature value displayed on the secondary LCD display. This sample has a temperature of 43.7 degrees Celsius. Clean the temperature probe of the pH meter and carefully store it. In this video, you will learn how to measure TDS in a water solution. Total solids is the term applied to the material residue left in the vessel after evaporation of a sample and its subsequent drying in an oven at a defined temperature. Total solids include total suspended solids, the portion of total solids retained by a filter, and total dissolved solids, the portion that passes through the filter. We are going to measure total dissolved solids using the evaporation method. First, you have to take a crucible and measure the initial dry weight of that crucible using a weight balance. Note down this measure as W1. Then you have to filter the sample using a Wattmann filter paper. Then take a 10 ml of filtered sample into a measuring cylinder and transfer it to the crucible. Next, place the crucible inside oven and heat at 103 degrees Celsius. After the drying process, cool the sample to room temperature in a desiccator. Finally, note down the final dry weight of the crucible using weigh balance and note it down as W2. In this video you will learn how to measure total suspended solids in a solution. Total suspended solids, TSS, is the dry weight of suspended particles, that are not dissolved, in a sample of water that can be trapped by a filter. First you have to take a filter paper and measure the pre-weight using a weigh scale. Note down that value as W1. Then the sample water solution should filter through the filter paper. In this case we have used the filter paper that already used in the TDS method. Next you have to place the filter paper inside the oven and heat at 103 degrees Celsius for 1 hour. Then you have to measure weight of the filter paper and note down this value as W2.